So anything that's going to decrease the number of organisms surviving is a limiting factor. And limiting factors can vary from year to year, month to month, because there might be a drought, so then there would be fewer that could survive because of water. But it will vary a little bit. Now, organisms have ways to help themselves survive better. So some will cooperate, and that allows more to survive in the area. And some will compete. So competition can lead to fewer that survive. So carrying capacity is actually a number we can measure. We can measure how many are in the population, and we'll learn ways that we measure that later on. And we can actually graph carrying capacity. But an interesting thing happens, because there are times when the population is going to grow, like when babies are being born in the spring, or maybe there's lots of food available all of a sudden. But then we get to a high number, a big population, and that's going to cause it to drop off again. So not all the babies are going to survive, some of the older ones are going to die off, so the population drops back down. So when we're looking at a graph of carrying capacity, to figure out the actual number, we have to look at a graph over time and see where the stable amount is. All right, here we have a graph of carrying capacity. You don't have this graph, so you need to pay attention, but you will be expected to learn how to read these types of graphs and calculate a carrying capacity. So the graph we would normally see would be this purple line. See how it bounces back and forth. So our population starts at 0, so this means it was probably something that people brought in or that was introduced. And it grows and grows and grows, and then it hits this peak. So the high point. But that's more than the area can actually support. So there's not enough food or water or living space, and they start to die off. We have this die-off period. But then it gets below the carrying capacity. So it builds back up, another peak, another valley, it keeps moving, peaks and valleys, and it fluctuates, moves back and forth. But we can figure out an average amount, and that's what this blue line represents. So this would be the average amount between the peaks and the valleys. And it's probably somewhere just a little above 1.5 million. All right, let's look at some real graphs. So here's Tasmanian sheep. They were introduced by farmers, growing for food and for wool. So grew and grew and grew, and they hit a peak. So even though this is farmers who are in charge of keeping these sheep alive, it still hits a peak that was more than could survive, and the population started to drop. It drops and drops and drops. So we have this peak, and it gets all the way to this low, low. And then kind of fluctuates a little bit more. Now notice over time it's fluctuating a little less. There's a little lower highs, higher lows, so it's closer to that middle amount. So the carrying capacity, I would try and figure out the average between these. So probably somewhere around here, just probably somewhere around 1.6 million or so. So the average between the highs and the lows. Now this graph is interesting because after the 1920s, see we have this peak here. And I might predict that means we're going to have a big crash. But I also know some things that were happening. We have new technologies appearing after the 20s. People were learning better farming techniques. So I probably want to see the future graphs. It could be that because of the changes people made to the habitat, so the increases of technology and things, it might be that the carrying capacity is increased to above 2 million maybe even. So carrying capacity can change if something in the environment changes. Farming is a good example of people in the real world who care about carrying capacity beyond just scientists looking at species. So here's an example from a farmer and what happened with their sheep when they tried to move where their farm is.
In Louisiana, we have 50 baby market lambs right now, which range from about 3 months old to about 4.5 months old. In Oklahoma, we have about 60 ewes, which are used for breeding to produce these market lambs that you see here, and they're on about 160 acres. When we first moved here for